So let's get a little bit more comfort in our understanding of what a differential equation even is. And so here we have a differential equation, and we haven't started exploring how we find the solutions for differential equations yet. But let's just say you saw this and someone just walked up to you on the street and says, hey, I will give you a clue that there's a solution to this differential equation that is essentially a linear function where y is equal to mx plus b, and you just need to figure out the m's and the b's, or maybe the m and the b, that makes this linear function satisfy this differential equation. And what I now encourage you to do is pause the video and see if you can do it. So I'm assuming you have paused it and had a go at it. So let's think this through together. So if we know that this kind of a solution can be described in this way, we have to figure out some m's and b's here. This is telling us that if we were to take the derivative of this with respect to x, we take the derivative of mx plus b with respect to x, that should be equal to negative 2 times x plus 3 times y. Well, we know y is this thing, minus 5. And that should be true for all x's. In order for this to be a solution to this differential equation, remember, a solution to a differential equation is not a value or a set of values. It is a function or a set of functions. So in order for this to satisfy this differential equation, it needs to be true for all of these x's here. So let's work through it. Let's figure out first what our dy dx is. dy dx is derivative of mx with respect to x is just going to be m. And of course, derivative of b with respect to x is just a constant, so it's just going to be 0. We could write m is equal to negative 2x plus 3 times, and instead of putting y there, I could write mx plus b. Remember, y is equal to mx plus b minus 5. And so if you weren't able to solve it the first time, I encourage you to start from here and now figure out what m and b needs to be in order for this equation right over here to be true for all x's. So I'm assuming you have paused again and had a go at it. So let's just keep algebraically manipulating this. So we have m is equal to negative 2x plus, if we distribute this 3, we're going to have 3mx plus 3b minus 5. And now we can group the x terms. So if we were to take these two and add them together, that's going to be negative 2 plus 3m times x. And then you have your constant terms. So you have these terms right over here. So plus 3b minus 5. And of course, that's all going to be equal to m. Now remember, this needs to be true for all x's. Over here, I have some coefficient times x on the right-hand side, but on the left-hand side, I have no x's. So somehow this thing must disappear. This is a constant, so it's completely reasonable that this constant could be equal to m. But the only way that I get these x's to disappear, so all I'm left with is an m, is if this thing is equal to 0. Let me say that again. M, some constant value, is equal to some coefficient times x plus some other constant value. Well, in order for a constant value to be equal to a coefficient times x plus some other constant value, the coefficient on x must be equal to 0. Another way to think about it is this should be 0x plus m. And so you see, you kind of match the coefficients. So 0 must be equal to 3m minus 2, and m is equal to 3b minus 5. So let's use that knowledge, that information, to solve for m and b. So we could use this first one. So 3m minus 2 must be equal to 0, or 3m is equal to 2, or m is equal to 2/3. So we figured out what m is. And then we could use that information because we know that m is equal to 3b minus 5. M is 2/3, so we get 2/3 is equal to 3b minus 5. We could add 5 to both sides, which is the same thing as adding 15/3 to both sides. So let's do that. 15 over 3 plus 15 over 3. These cancel out. That's just 5 right over there. On the left-hand side, we have 17 over 3 is equal to 3b, or if you divide both sides by 3, you get b is equal to 17 over 9. And we're done. We just found a particular solution for this differential equation. The solution is y is equal to 2/3 x plus 17 over 9. And I encourage you, after watching this video, to verify that this particular solution indeed does satisfy this differential equation.